Hello everyone. Today we'll be solving the problem number 215, kth largest element in an array, right? So what the question states here, we are given an array nums. You can clearly see here, we are given an array nums and an integer k and an integer and an integer k, right? So we need to return the kth largest element in the array. We need to return the kth largest element in the array. Means here second largest element in the array according to the question, right? For the example one. Note, so I'll just read out the note. This one, just listen to this. This is based on the sorted order, not the distinct elements, right? So this is based on the sorted order, not the distinct elements. So we have to avoid the sorting the array directly. So we have to avoid sorting the array directly, right? So we shouldn't be sorting this one. See here, can you solve it without sorting? They have asked. So we need to avoid the sorting. We need to avoid sorting the array directly. So we can just make use of the heap or the priority queue for the better performance here, right? Basically, we have to find the kth largest element in the array, right? So we can go with a max heap and take out the second element, second largest element, like that accordingly with the k, right? So that we can do. So that is the reason we'll be making use of the priority queue. So priority queue will be handy for this particular problem, right? So this problem is designed to be solved with a heap or the priority queue, right? So this is one of the best problems to solve with a priority queue. So just give me a second here. One second. What happened here? Yeah, this is fine, man. Yeah. Now, one second. Yeah, we have the nums array 3 to 1 5 6 4. Here we have the maximum element as 5, the 6 maximum, second maximum element is 5. So the output that we have got here is 5, right? So here in the second example, the maximum element that we have is 6 5 4 and then 3. 6 5 4 3 2 1 is the elements we have. The fourth largest element we have to return here, k equals 4. We have been given k equals 4, right? So we have to return the fourth largest element, means 6 5 4 3. Sorry, 6 5 4 3. We have to go with the 3, right? Then why we have went with this one? Just give me a second, 1 second here. There might be some problem. We have 6 here, 5 4. Oh yeah, we have, oh, this one also we have to consider, man. If the elements are repeated, that one we have to consider as well. We have the element that is repeated twice here, right? So we have the element 5 that is repeated twice. Here in this case, see, we have the element 6 only once. If the element 6 was this one, what do we call? It was repeated again, then we would have went with k equals 2, then we would have went with 6 itself rather than the 5, right? So here in this case, the fourth largest element would be 655. This one 4 we have, right? 655 4 we have. So 5 we have to consider twice. In this case, we have the we have to return 4. Sorry, I got confused here, man. Yeah, 4 we have to return, right? 6 5 4. So this is the fourth largest element, right? So this is fine. So now, as I have said, we will be making use of the maximum priority queue. We will be making use of the, sorry, minimum priority queue. So we will be going with the minimum priority queue. So I said, did I say that maximum will be making use of the maximum here? No, right? So we will be making use of the minimum priority queue. I think I had said maximum priority queue. Sorry, we'll be making use of the minimum priority queue for this one, right? So here, accordingly with the question, so we have been given the integer 2 for the k, right? So we have to go with the second largest element here. First, what we will do, we have to create a minimum heap of size k equals 2. We have to create a minimum heap of size k equals 2. Size k equals 2. So let me go with the k equals 2. This is fine. Now, this heap will store the top two largest element, that's top two largest elements that has seen so far. That's seen so far, right? So first we will add 3. So we have the element 3 here. First we will add. First we will be adding 3. So heap consists of 3, right? Heap consists of 3 for the first one. Next, what we'll do? We'll add 2. We'll add 2. So heap consists of here now 2 and 3. 2 and 3. So this is heap, right? So priority queue first and first out, right? So this is fine. So we will be adding one next. We will be adding one next. This one will be this one. We will be popping one here. We will be popping one because priority queue, we will be considering the size of the k. The priority queue size will be considering this one. The priority queue size will be based on the k, right? So k we have been given 2, so we will be going with a priority queue of size 2. So now we have the two elements already in the priority queue. Now we have the two elements in the priority queue, so we will be considering this one. We will be popping one, so we cannot push this one to the priority queue. So push this one to the heap or the priority queue. So we will pop one. Why we will be popping one? Because one is the smallest among 1 2 3, right? Luckily we have got one here which is smaller than 3 and 2, right? So we will be popping one. Basically now it will be 2 and 3 itself. 2 and 3 itself, right? So next what we will be doing, we will be adding 5. We will be adding 5. We have to add 5, right? So what we will do, we have to pop 5 among 5, 2 and 3, which is the smaller one, 2. So we will be popping this one 2. Now it will be 3 comma 5. Now it will be 3 comma 5, right? So next step is we have to go with the element 6. We have already added 5. Now we will be going with the 6. So 6. So we have the 3 and 5 in the heap. 3 and 5 in the heap are the priority queue. So what we should remove? The smallest element. So we will be removing the smallest element 3 from the heap. So this will be 5 comma 6. This will be 5 comma 6, right? So next we are done with the 6. We are left with only one number, that is 4. 4, right? So now we have 4. We have to add 4 to the heap. So among 4, 5 and 6, which is the smallest? 4 is the smallest. So we will be popping 4 itself. So this remains 5 6. 5 6 as it is. 5 comma 6 as it is, right? 5 comma 6 as it is, right? Now the top of the heap is the minimum of the largest k elements. The top of the heap is the minimum of the largest k elements, that is 5. The top of the heap consists of the 5. We are going with the minimum priority queue. Sorry, I said we'll be making use of the max heap. Sorry, we'll be going with the minimum priority queue. Initially I had said we'll be going with the max pq, right? Sorry, I got confused, right? So here, the top of the heap is nothing but the minimum of the largest k elements, that is nothing but 5. So this 5, the top of the priority queue, this value we will be returning as output, which is the second largest in the array. That's what they have asked. So the output that we got here is 5, which is equivalent to the output that they have shown for the example 1 within the question. Follow the same steps for the example 2, right? I insist you to follow the same steps for the example 2 so that you understand the question better, right? So we will get the output 4. We'll get the output 4 for this, right? So I hope the this one approach part is completely clear, man. As we are done with the approach now, we can move on with the complexities part. So what will be the time complexity here? The time complexity would be big O of n log k. The time complexity would be big O of n log k, right? So here insertion and removing from the heap takes log k. Insertion and the removing, this part I am speaking, this one takes log k. Insertion and deletion, or insertion and removal, let me consider this one, right? Insertion and the removal from the heap takes log k, and we do it n times. So overall time complexity would lead to big O of n log k. Overall time complexity would lead to big of n log k. So what will be the space complexity? The space complexity would be big of k. Why it will be big of k? Because the heap size is maintained at most k elements. The heap size is maintained at most k elements. Again, I'm telling the heap size is maintained at most k elements. So overall space complexity would lead to big of k. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n log k and big of k respectively, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. Right. So first step in the approach was we have to create the minimum heap or the min priority queue just to store the k largest elements. Let's go with the priority queue. Priority queue. This one will be integer. Integer. So this one pq equals new. So this one is priority queue, new priority queue. This is fine. The next one is we have to iterate over each number in the array. We have to iterate over each number in the array. So for int num of nums, so within this for loop, we have to add the number to the heap. We have to add the number to the heap. To For adding the number, so we can just make use of the offer operation that is provided by the priority queue, right? So I'll just go with offer of num. We are just adding the priority, adding the number to the priority queue. So or adding the number to the heap. So the next step would be if the heap size exceeds k, then we have to remove the smallest. That's what we did in the approach, right? If the heap size or if the priority queue size exceeds k, then we have to remove the smallest, nothing but we have to keep only k largest. We have to keep only k largest, right? So let's write the simple if condition here. If pq dot size, if it is greater than k, then we have to remove the smallest in the k plus 1 size heap, nothing but pq dot poll, right? So this is fine. We are just removing the smallest in the k plus 1 size heap, right? So this is fine. The final step here is we have to uh, return the topmost element that is present in the heap, min heap, right? So here the top of the heap is the kth largest element. We know this from the approach. Let's return the root of the minimum heap, nothing but it is root. So how can we return the top of the heap? Basically we'll be making use of the peak operation, right, that the priority queue provides. So I can just write here return pq dot peak. So this is it for the code, right? So simple one. So let me hit the run button here. I hope this works for all the test cases, man. Let's see. So yeah, sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.